Okay, so we're looking now at the next part of the statistics, which is continuous random variables. So the work you've been doing already involved discrete. So discrete just means things that can be counted, okay? It's things that can be counted. Discrete, so you have to have whole numbers, okay, like 2s and 3s or whatever. Okay, but with continuous random variables, these involve things that can be measured, okay? And you've already been doing this, so copy that and come across. So I said you've already been doing this because you've been doing the normal distribution, which is a continuous distribution because you can assume any values. Okay, so you've already been doing it, but it's sort of a different approach. Okay, so copy that down. Come across. Okay, so like in the normal distribution, we have the bell curve. So what we're looking at are things that can be measured, and we're measuring from 0 to whatever value, and we have a function which can be graphed. Okay, so the smooth curve that is formed is called a probability density function, but we're just going to use PDF as the shortcut for that. Okay, so when you see the question about PDF, it's just a probability density function. Okay, copy that, come across. Okay, so again, just some of the things that we should all be aware of. The area under the curve must equal 1 for it to be a PDF. If the area doesn't equal 1, then not a PDF, which means you can't do any questions really. Okay, and then just like we did with the normal distribution, the area between two numbers is the probability that the event will be between those two things. Okay, so just like with the normal distribution. So copy that and come across. Okay, so we've got an example here, and the first ones are fairly straightforward. Sketch the graph of the following and state whether it may be a PDF. So it may or may not be. So we've got a function, and it doesn't have to be a bell curve. It's just any lines can make a function. Okay, so in this particular one, the way it's written, we've got this long symbol, which I never know what it's called, but whatever, long bracket, and it equals 4x between 1 and 2, and it's 0 everywhere else. So what's happening is in this section between 0 and 1, it's 0. And between 2 and infinity, it's 0. Okay, so elsewhere. But between 1 and 2, it's a straight line equal to 4x. So what I've got is between 1 and 2, I've got 4x. So when x equals 1, 4 times 1 is 4. When x equals 2, 4 times 2 equals 8. So what I've got is this sort of shape here. Okay, so that shape is a shape, and it's called a trapezium. So the area of a trapezium equals height onto a plus b. Like most of these will turn into triangles or rectangles, but this one's a trapezium. Could be a triangle, but it's not. So we could do it as a triangle, sorry, but we won't. So the height is the distance between those two numbers, which is 1 on 2. A is 4 and b is 8. So we've got a half of 12, which is 6, and 6 does not equal 1. Therefore, it's not a PDF. Okay, so the area has to be equal to 1. And obviously, if you wanted to, you could do it as an integral, like from 1 to 2 of 4x dx, which is, straight curve line. So 4x turns into 4x squared over 2. Between 2 and 1, 2 into 4 goes twice. So we've got 2 times 2 squared minus 2 times 1 squared. 2 squared is 4, 4 twos are 8, minus 2 equals 6. So you get the same answer by integrating or by the shape, but regardless, it's not a PDF. So in the questions that you'll be practicing, you'll be asked to draw it, and then just find the area under the curve either by integration or by just using what the shape is. Okay, copy that and come across. Okay, so this next one's, you're told that it is a PDF, okay, and what we got is, this is the notation that they're using in the textbook. So what this is saying, this part here, there's a function, and this part says between 2 and 4. Now, the curve bracket, the straight brackets means it's like 2 less than equal to x less than equal to 4. Whereas if it was a curl bracket, it'd be 2 less than x or something like that. So, but these are straight ones, so it includes the values at 2 and 4. And this says that we're putting it onto real numbers. Okay, so that's the language. But basically, here's the question over here. The function is a bracket 12 minus 3x. Now, because we're told it's a PDF, that means that the area equals 1. Okay. Now, we don't know what it looks like, but we know that the area equals the integral from 2 to 4 of a 12 minus 3x dx. So that's what the area equals. And we know that the area equals 1. Now, a is a constant, so I can take that outside, and then I integrate those numbers. So 12 turns into 12x, and 3x turns into 3x squared over 2 between 4 and 2. Okay, so we're just going to use our integration from the last semester. So 1 equals a. Okay, so then 12 times 4 minus 3 times 4 squared over 2. I better put another bracket around there. Minus 12 times 2 minus 3 times 2 squared over 2, close, and then giant bracket there. Okay, so we've got, move across a bit, 1 equals a. Okay, 48, 4 squared 16, 16 threes are 48. 48 over 2 is 24, so 48 minus 24 is the first number, minus 12 twos are 24, 3 squared, 2 squared is 4, 4 over 2 is 2, 2 threes are 6, so that's 24 minus 6. Okay, getting there. 1 equals a, 24 minus 18. Therefore, 1 equals a times 6. So a equals 1/6. Okay, so finished up nicely. Just a bit of integration you had to do. Okay, so we're told it's a PDF. So the area must be equal to 1, so you have to use your integration skills from the last semester. Okay, so copy that, and when you're ready, come across. Okay, so there's the exercise to do, 12A on page 580, question 1 to 8. Don't do all, just do a variety. Okay, so that's it. Thanks, bye.